Why, hello, geometry students, and welcome back to another video lesson. Today we are going to cover lesson 6-1, the introduction to symmetry. Really, what we're looking at today is, can you describe the reflection symmetry of figures? We did a little bit of reflections when we did rotation, reflection, and translation back in first semester. And so we're just kind of going to expand this a little bit further and really get a better understanding of what symmetry is. A figure is called reflection symmetric if and only if the figure reflected over the reflection line is the exact same identical figure. Right? So if I reflect this smiley face over the line, all of these points on the right side end up over here on the left. All the left side ones end up over on the right. We end up with the exact same figure yet, the smiley face. If I take this triangle with two congruent angles, if I flip all of the right side over here to the left and all of the left side over to the right, we still have that same identical figure. This would be a good definition for you to write down in your notes and maybe pause the video here to just get that down. But a lot of figures might have more than one line of reflection that allows them to have that identical figure on one side to the other. So let's see if we can't put that into practice. One of the things you'll have to be able to do is to draw at least one reflection line on certain images to show how and where they reflect. Now, as we draw these, I'm going to grab a red pen. Remember, if I draw it, one of the other ways to think about it is, do the two halves match up, right? Do I get two equal halves if I fold them in half, which would be true for this star this way, right? I would fold this tip and would end up over here. The bottom tip on the left would end up over here. And then if I truly reflected, all of these points would end up on the left-hand side, and it would still look like that star. Now, I could also have drawn it maybe a little bit differently and drawn it maybe through this point down here. And some of you said, well, what about that one? Yeah, that one works as well, right? This point would end up over here. This one would end up over here, and vice versa. What about this flower snowflake looking thing, right? Well, we could draw a line vertically through it, and this half would equal that half. So that would be one possible way. And we could do that, through any one of those, I don't know, petals or whatever they're called. Those would all work. But is there a potential of drawing it right here through the middle of all of those spaces? Well, there certainly is, because this would end up to there, and this point over here ends up there. So we would reflect it over that whole entire red line and still end up with the exact same original image. And that's the nice part about these reflection symmetries, right? Like if I tried to draw it this way and reflect, those are definitely not going to have the same image, right? Not going to look the exact same as what we started with. Whereas if I draw it through here vertically, at least in the right spot, hopefully, it's a little off-centered. I should redo that probably. I want to go like right. Oh, that's even better. The two sides, so that if I reflect it. And that's truly what we're looking at when we look for these reflection lines and reflection symmetry. Now, what we get is the notation, right? And remember this notation for reflection. Lowercase r over a certain line of the pre-image, right? This was the pre, would give us the image. And in this case, line M is the angle bisector. Right? It cuts this angle A in half, meaning if I reflected it, right? If I moved this point, same distance on the opposite side, and I move this point, same distance on the opposite side, what happens when we reflect that is point C will end up over here, and point B will end up over here. So to have the same image, to go A to B to C, we then in the new image would need to go A to C to B, right? Because C would end up over here in the B spot, and B would have ended up in the C. So we write it in that same orientation now, where we're going the same way clockwise around that shape. Well, what does that mean over here in this example? If we have a square, for example, where I have a line DU as the reflection line, we typically are going Q to U to A to D. That's the pre-image. Q to U to A to D. D and U are staying right in their spots if I reflect. But on the other hand, Q, if I reflect it, is actually going to end up down here. And A is going to end up right over here where the Q was. And so if we want to go in the same order, Q to U to A to D in the pre-image, we actually start with A and then go to U and then to Q and then to D, which is what's written in that as our final image. So the order in which we still write these letters is really, really important, and we must pay attention to that, right? It's imagining if we're flipping everything to the opposite side, but the reflection line and those points stay right on that. So let's try a few of these and see what happens. Okay, in this figure, it is reflection symmetric over SW, right? Meaning this line from S to W, it's not a good line. Come on, Mr. Goodacre, get with the program. There we go. Whoops, I had it. See, even teachers are going to make mistakes. There we go. There's the reflection line. Okay, it's reflection symmetric over that. And the original pre-image goes S to T to U to V to W to X to Y to Z. That's the order. If I were to reflect everything, what would end up here in T? Well, hopefully you said Z. What would end up here for U? Hopefully you know that that would be a Y. What would end up here for V? Well, that would be the X if I reflected it. What would stay here? W's on the line, so it stays there. What would come over here for X if I reflected everything? That becomes the V. The U comes over here for the Y, and the T comes over here for Z. So if we go in the original order, clockwise, S to T to U, let's think about it for the blue letters now. S to Z to Y to X to W to V to U to T, right? That's what it would equal. And because of that, we can see that S is in the same spot and W is in that same spot because they were on the reflection line. But we're imagining what happens when we flipped everything over, okay? So here we go. Oops, we did that one right here. We did that one right down here. Well, angle T, right? Angle T is really congruent to which angle? Angle Z. They're in that same spot, right? They're corresponding. T to U. T to U is the same one over here as Z to Y. And notice, because we wrote down those, it makes it a little bit easier for us to see. All right, take a moment. See if you can answer X. Angle X is congruent to what angle? Segment ZS is congruent to something. Segment SY, segment WZ. See if you get those four. All right, hopefully you paused it and you tried them. Angle X, remember, is the same as angle V, so that's going to be a V. ZS, Z to S is the same as T to S, so that's going to be a TS. Oops, I forgot my segment marks here. Segment SY, right? Segment SY. It's not on there, but if I drew it, it would be this one, right? Well, what letter is the same as Y? U. So segment SU would be the correct one. And W to Z, right? Again, I don't have W to Z on here, but if I drew it, WZ is the same as W to T. It would be the same distance and would be congruent. So that's what we're really looking at when we talk about reflection symmetric, right? We're talking about if I took the whole shape and flipped it over, what would be in the same spot as the original points. If you have questions, please make sure you reach out. Try the practice problems today. Again, they're the best way for you to understand if you know this content. And if you have any questions, please make sure to hit me up. Until next time, everyone, stay safe.